Hey, welcome back to your favorite trigonometry class. We're going to look at some double angle and half angle formulas. Here's our some double angle formulas here. Um, you're going to see this one a lot. Definitely memorize that one. Sine 2 theta equals 2 sine theta cosine theta. And you can use any of these three for cosine 2 theta. It just depends on what you're trying to achieve. You know, the first one has cosines and sines in it. Second one's just got sine squared, so it's got sines in it, and this next one's got cosine theta. So depending on your uses, there's which one you want to choose. Let's go through sine 2 theta, that proof there, just so you know where this comes from. If you recall the sum formula, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, right? Well, 2 theta is just theta plus theta, right? That's 2 theta. So alpha's theta, beta's theta. So this just becomes, according to our sum formula, sine theta cosine theta plus cosine theta sine theta. Well, these are the same term. I have two of those sine theta cosine theta. So the sine of theta plus theta, so the sine of 2 theta is 2 sine theta cosine theta. So let's work some examples though with this double angle formula. So the sine of, if the sine of theta is 5/6, and we know theta is less than pi but greater than pi half, so we're into quadrant 2 here, right? And sine of theta, so we got opposite over hypotenuse, right? This is theta, we're using theta prime, the reference angle, so 5/6, opposite over hypotenuse there. And then we'll go ahead and we'll solve for that remaining side. We'll call it A. So A squared plus 5 squared equals 6 squared. So we got 36 minus 25. We got 11 here. Square root is plus or minus root 11. We're going to name it negative root 11 so that our cosine, just because our cosine, I know that's a distance again, but because our cosine, we're using right triangle trig to do this. But because our cosine in quadrant 2 needs to be negative, so we'll name it negative root 11 there. So A is, equals negative root 11. Sine 2 theta then becomes sine 2 theta, according to our double angle formula, is 2 sine theta cosine theta. Well, we know the sine of theta is 5/6, and then I look at the cosine of theta, which is adjacent over hypotenuse, negative root 11 over 6. So we got negative 10 root 11 over 36. 10 and 36 both go into 2, so we got negative 5 root 11 over 18. Okay, let's do it for cosine 2 theta. Now cosine 2 theta, again, I can use any of these formulas. Maybe I'll use that one because I just got sines in it, but again, you can use any of them. So cosine 2 theta is 1 minus 2 sine squared theta. So 1 minus 2, I got a sine theta times another sine theta. Well, we know the sine of theta is 5/6. So we got 1 minus 50 over 36. In other words, 36 over 36 minus 50 over 36. We got negative 14 over 36, or negative 7/18. That's cosine of 2 theta. Now, in developing a formula for tangent 2 theta, what we can use is use the fact that the tangent of alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta, right? So we can use this. We can use this formula to do it with alpha and beta being theta. And you can develop a formula for the tangent of 2 theta. So the tangent of 2 theta ends up being, well, tangent theta plus tangent theta is 2 tangent theta. And then tangent theta times tangent theta is tangent squared. So here's our tangent of 2 theta. You could do the similar procedure for for sine of 3 theta. We'll just walk you through that. So that would be sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And then we know sine of 2 theta is 2 sine theta. And I'm going to use the fact that cosine 2 theta is cosine squared minus sine squared. Then I multiply those, 2 sine cosine squared. Let me distribute that. And then I'm going to combine the sine theta cosine squared. So there's 3 sine cosine squared minus sine cubed. So there's a formula for the sine of 3 theta, just using the sum formulas there. All right, here's some formulas that are called power reducing formulas. So sine squared, you notice it's a power of 2 right now, sine squared, but then it goes down to, there's no powers of 2 over here. It's just 1 minus cosine of 2 theta all over 2, right? So it reduces the power. That's what it's called. So let's go ahead and write an equivalent expression for cosine of 4 theta by using those power reducing formulas. So I know that cosine of 4 theta is cosine squared, right? So that's like cosine squared, right? It's cosine of 4 theta. So now I'm going to replace cosine squared theta as 1 plus, so I'm going to use the power reducing, 1 plus cosine 2 theta. So I look back at those formulas all over 2. So there I just power reduced cosine squared theta. Then I know it's still squared. Now what I'm going to do is I'm going to expand that. I have 2 of those 1 plus cosine 2 thetas over 2 being multiplied. So when I multiply this by itself, right, on the top is squared, bottom is squared. Of course, the bottom is 2 squared is just 4. But when I FOIL the top, I get 1, I get 2 of these cosine 2 thetas, and then I got a cosine squared of 2 theta, right? And now I've got to power reduce this one right there, okay? So again, I'm using the fact that the cosine squared theta is 1 plus cosine of 2 theta all over 2. But this time I have, notice, I have 2 theta in there. So cosine squared of 2 theta would be 1 plus cosine of 2 times, what's theta? It's 2 theta here. So cosine squared of 2 theta using that power reducing formula is 1 plus cosine of 4 theta all over 2. Okay, that's what's going to replace this right here. So I have 1 plus cosine 4 theta all over 2. And then the rest of this comes along. So we got 1 plus 2 cosine 2 theta plus that. And this is all this junk's all over 4. Right, which means each of these terms, I got 1/4, I got 2/4 cosine 2 theta, and then I got this all this junk over that, which means, I got 1/2 over 4, so I got an 1/8. I got cosine of 4 theta over 2 times 4 over 8, right? So we've got 1/4 plus 1/8, so I got 3/8. I got 1/2 cosine 2 theta, and then I got an 1/8 cosine 4 theta. And notice I went from a fourth power, and none of these are all to a degree of 1, cosine to a degree of 1, right? Cosine 2 theta, cosine 4 theta. So I power reduced that. All right, let's solve this equation here. We've got sine theta cosine theta equals negative 1/4. What I'm going to do here is I'm going to say, well, I know 2 sine theta cosine theta is sine 2 theta, so I'm going to multiply this side by 2 and that side by 2. So I have 2 sine theta cosine theta equals negative 2/4, so negative 1/2. So the reason I did that is because I know 2 sine theta cosine theta that double angle formula that I memorized is just sine of 2 theta. So then I can say, oh, the sine of what is negative a half? I know sine of 7 pi 6 is negative a half. I also know the sine 11 pi 6 is negative a half as well. So where does 2 theta equal 7 pi 6? In fact, I'm going to do this. It's 7 pi 6 plus any 2k pi, where k is an integer. And then I'm going to divide everything by 2. So theta ends up being 7 pi 12ths plus k pi, where k is an integer. Okay, there's one set. And then where does 2 theta equals 11 pi 6? And I'm going to do all plus 2k pi, right? Where k is an integer. Divide by 2. So I got 11 pi 12ths plus k pi, where k is an integer. So we've got theta being, if k is 0, I got 7 pi 12ths. If k is 1, then I got 19 pi 12ths. If k is 2, I'm too big. I gotta, I'm outside my 2 pi there. Let me go over here to 11 pi 12ths plus k pi. So I have k is 0 is 11 pi 12ths. I don't want to let k be negative 1 because I go into the negatives, and I'm trying to stay again between 0 and 2 pi. If k is 1, then I've got 23 pi 12ths. Again, if k is 2, the next one would be 35 pi 12ths. Well, that's too big. So here's all my solutions for this equation here. Okay, whoops. Here's sine squared of alpha over 2 formulas, and then these lead to our, if I square root, these lead to our half angle formulas. You'll see these quite a bit as well. They're called, again, half angle formulas. Now notice it says plus or minus. Well, the plus or minus depends on the angle. Where is alpha over 2? Well, then I know if the sign is positive or negative based on that. So let's do cosine 75 degrees. Well, I know 75 degrees is the same as 150 degrees over 2, right? So according to our half angle formula, we have cosine alpha over 2 is plus or minus 1 plus cosine alpha all over 2. Okay. Now, first of all, 75 degrees, the alpha over 2, right? 75 degrees, where's 75 degrees? Well, it's right here. So the cosine's what? Positive, right? The x value, that cosine is positive. So I know it's the positive one. And then I take, well, I know the cosine of 150 degrees. Cosine of 150 degrees on a unit circle is negative root 3 over 2. And then we just clean this up. That's 2 over 2 minus root 3 over 2. 2 minus root 3 all over 2 all over 2. So 2 minus root 3 over 4. Square root of top over square root of bottom. So there's cosine 75 degrees, the exact value. Sine of negative 75 degrees. So I'm going to think about this as sine of negative 150 degrees over 2. And then I'm going to follow sine alpha over 2 equals plus or minus 1 minus cosine of negative 150, then the alpha all over 2. Now, negative 75 is right here, so my sine is negative there, right? So I got to think about where that's at. That's why I picked the negative. So negative stays there. And then I got cosine of negative 150 is negative root 3 over 2. So we got negative root 2 plus root 3. This is all over 4, root 4, which is just 2. And there's sine. So there's our sine of negative 75 degrees. An exact form there. Okay. All right, let's do another one here. We've got cosine alpha. We want to get a picture of this. This is less than 3 pi halves. Alpha is less than 3 pi halves, but greater than 0. So we're into quadrant 3 here. Here's our alpha. Now cosine of alpha, adjacent over hypotenuse. Right, so the adjacent over hypotenuse. Go ahead and solve for that other side. So a squared plus b squared equals hypotenuse squared. So b squared equals b equals plus or minus root 5. And name it negative root 5 because our sign is negative in quadrant 3. Okay, so we've got that. And then also note one more thing here. Note alpha is less than 3 pi over 2 and it's greater than pi. So when I'm finding sine of alpha over 2, because I'm going to have to decide whether it's the positive or the negative one. So when I divide this all by 2, alpha over 2 is greater than pi halves, but less than 3 pi 4. So here's alpha over 2, right? So the sine of alpha over 2 gives you the option, it could be plus or minus 1 minus cosine alpha over 2. I say, well, the sine, the y value is going to be positive, so I'm going to pick the positive one. And then I'm going to go through with it. So it's the positive one. 1 minus, and then I say cosine alpha, so I go cosine alpha adjacent over hypotenuse, negative 2/3, all over 2. So 3/3 plus 2/3 is 5/3 divided by 2 is 5/6. So we got square root of 5/6 or square root of 5 over square root of 6. Rationalize that. So we got root 30 over 6. Okay? And similarly for that cosine alpha over 2, you're going to be negative. There's your cosine's negative there on that alpha over 2 in that second quadrant. So you pick the negative one, and then you just go through it. Right? You replace cosine alpha, negative 2/3, work through it. Tangent alpha over 2, the sine over the cosine is negative, right, in quadrant 2 for the alpha over 2 location. So you pick the negative one, and then you plug in cosine alpha and cosine alpha there and clean it up. Okay. Lastly, just be aware there's also half angle formula tangent alpha over 2. You could also use either of these two forms as well, okay, to get an exact value. Thank you so much for listening. We will see you guys next time.